Hi everyone, welcome to our live stream, episode 207. This is our first quarantine live stream since the team got separated because of COVID-19, but that's okay. That's just what's going on in the world right now. But yeah, this episode is going to be about voice controlling your light so you don't have to touch it. Nobody wants to touch anything anymore. So yeah, I'll pass it on to Alfred. We can introduce ourselves again. I don't know if we want to do that. What do you think, Alfred?
Yeah, sure. I'm Alfred. Hi.
And I'm Sumrine.
Yeah, she's
Yeah,
on. Okay.
and this is your live stream crew. Yeah, we're in different locations now, but yeah, this is we're still bringing tutorials to you, and hopefully you like it.
Yeah, from our homes.
Yeah. Note, we are using a new software, so if you have feedback on I don't know, anything, let us know in the comments, and we'd love to hear what you have to say.
There's some cool transitions that you will be seeing in a moment.
Yeah, it's definitely cool transitions that we've all pre-programmed. It's all our doing.
Oh, yes. We spent many hours doing this. It wasn't at all already there for us.
All right, Alfred, take it away.
Cool, yeah. So this guide is going to show you how to make your own voice-controlled lights with Rhasspy and the Matrix Voice. If you guys remember, last year we released a very similar guide, but it was for how to do it with Snips. Snips has since been defunct, bought by a company and no longer available for public use, but now we have Rhasspy. So what Rhasspy is, it's a completely open source software that puts together a bunch of other softwares, algorithms for being able to do privacy-focused offline, running at the edge voice services. So it puts together, what is it? Porcupine is the wake word. Pocket Sphinx to do the general NLU. And then, yeah, a bunch of other options there, and you can pick and choose and customize it. So it's really good. It has a really nice interface. And like I said, it's all open source. And the guy who made it is constantly adding updates. So it's a really cool software, and we really like it. So, what? And then, this is this is a great topic for nowadays when we're in this different time. We don't really want to be touching light switches or just touching anything really. So having a voice controlled light switch is really good right now. And in general, whether you're at home and you don't want to get out of bed to turn off your lights, or if you have an office and you're tech savvy and you want to just implement this within your office so that nobody there, if and when they come back, are able to switch the lights on without touching anything. So let's go to the guide. Made a beautiful Hackster guide, released a couple weeks ago, but here it is. Ta-da, Hackster. So you can find the guide on hackster.io/matrixlabs, which is just our general platform. And then the link to the guide will be in the description of this video as well. So here it is. Cool GIF. So the wake word that it uses, as you can see, is porcupine. And what we're going to be having it do is turn on and off the lights. So it's going to be a Matrix Voice right here. You can see, right? With a Raspberry Pi. So connected to a Raspberry Pi using a relay. So the power to the wall, to the light switch is going to come into here, and then these will go to the Raspberry Pi. And then you'll be able to talk to it and enable and disable the relay to turn on and off the lights. So I'm getting ahead of myself. Let's start off with the code. Let's see here. So here's the guide. Everything you need, like what I said. Rhasspy. There's a little video here showing it working, but I have the actual device right here, so you'll see it live at the end. I took this off my wall this morning. So how can enterprises use it? I already covered that. Hardware that you need to use. internet connection. So let's get started. So what you want to do is you want to make sure you have a matrix creator, matrix voice. We're going to be using a matrix voice in this case just because it's smaller, and this specific project doesn't use all the other sensors that the matrix creator has. But all of this would definitely work on a matrix creator. You just wouldn't be able to use the 3D printed case, which is like fit for a matrix voice. You can see here, the creator's kind of bigger than it. So you want to make sure you do the setup for the creator and voice. Already done that. Enable SSH on your Raspberry Pi. I've already done that, and there's links here that you can go to learn how to do that and what that means if you don't know that already. Then you want to install the matrix libraries and Rhasspy. So you have to install matrix how, which is like our C++ layer. Want to install matrix light.js, so that is like our very abstracted layer that allows you to very easily program everything in JavaScript, and then installing Rhasspy itself. So these are all guides that we have. You can click to it. For example, this one is our Rhasspy guide and how to set it up, and it goes through everything there. So I won't go through that now. So next thing is creating an intent. So you want to make sure you have the IP address for your Raspberry Pi. If you don't already have that, well, you should have that from these steps. So I'm going to assume that you already have that. So I'm going to move this window over. Let's see. And then here. So the IP address for my Pi is 192.168.0.152. Yours will be different, most likely. And then port 12101, as it says here. So you want to make sure you replace that. So here's the interface for Rhasspy. This is actually like a local website running within your network that has Rhasspy running. So we're connected to the Raspberry Pi that I have running right here. And then this is it. So you have speech here. You can add like your own audio files to it. Sentences. So this is where you would tell it like the intents and everything that you want it to understand and then feed back to your code. Slots, if you want to get more specific. So it has some examples here. And we have a guide that also goes through all this. Words, if you want to give it like specific definitions, like here I already have some for like toggle, disable, enable. It's really simple. You just type in a word and you're good. And then a bunch of settings, some advanced stuff, log. So what we're going to do in this step is go to sentences, and then, so right here, matches more or less. And then we're going to go here. We're going to copy this. So take away all that and copy this part. So light, that's just a label for what this is, and what it's going to be listening to is turn the light on off. So it's going to, the bracket here, the square bracket means that that's an optional character. So if it hears turn light on or off, then it will work, but it'll also work if it hears turn the light on off. And then this right here is basically like the intent. So it's associating that if it hears on and then the option or off, it'll be associated with an intent called power. So when you see that in your code, and we'll explain that in a little bit, that's what it's going to be labeled as. So it's very easy to process. And then here's just another phrase that we can have. So light on or off rather than turn. I've noticed that it's better that you don't start it with an optional option in the sentence. So have the sentence start with like a word that it's for sure hearing and then the rest. So that's why we have like two here. So once that's there, we want to click Save Sentences, and then it's going to train Rhasspy. So all this training is happening locally on the Raspberry Pi. And you can see up here the R indicates that it's running. And it's just running through the training. And this takes maybe like 30 seconds or 12.68 seconds. There we go. So useful. Let me make sure I have the comments up here too. Cool. So now we have the sentence trained. That's good. Now off to the code. That was it for Rhasspy. Super simple, right? Once you do the setup beforehand, which is also simple, just running some commands, this is all you have to do on the Rhasspy side to turn the lights on and off. Incredibly simple. So now we want to actually get to the actual code. So you want to make sure you are SSH'd into your Raspberry Pi. So I'm going to switch over here. Here's my terminal. Get a SSH in. Oh, hide. I didn't realize I had that. Okay, so yes. Raspberry is the password. Don't tell anybody. Let's see. Okay, cool. This is it. So yours will probably say Pi at Raspberry. I changed my host name, or Raspberry Pi. I changed my host name to Hallway Light Switch just because I have multiple Pis and it makes my life easier. And you can look up how to do that yourself. But don't worry if that looks different than your screen. So first thing is we want to install Git. I already have Git installed, but I'll run the command anyways. And see, so it's just going to go through some things, installing Git. It should be quick if you don't already have it installed. And for me, it's already done. So now we're going to go into the light.js directory, which you should already have based off of like following the getting started steps. So in the light.js directory, and then we are going to get these 3 files from our GitHub. So it's going to be assistant.js here, everloop.js, and relay.js. So this is all the code. We've provided it for you. So if you want, you could just copy and paste the code that it says on the guide, or this is an easier step so that you know that you actually have the code. And then from there, you can build off of this if you want. So that's it. So we'll do ls to list. So we have assistant.js, everloop.js, and relay.js. So all good there. Note for you, you won't see backup. That is just my backup code, just in case something goes awry. But we should. Thank you. This is actually the device I had running in my hallway and that you saw in the videos. So I know it works. And all this code should work as well. Fingers crossed, but it should.
Yeah, you never know what happens in live streams. It's like luck just goes out the window.
Yeah.
But I have faith. Today is the day. It's going to be on our side.
Yes, please. Okay, so now we want to install the project dependencies. So we're going to install WS, which is WebSockets, which is how we're going to be listening to the events happening from Rhasspy. And then we're also going to install HTTP, which is just to connect to Rhasspy. Yeah. So here, let's download this. I should already have this, but let's see what happens here. Okay, and now HTTP. So looks like this is good. Here, I'll make this a little bigger. So this program, by the way, that I'm using is called VS Code, Visual Studio Code. Great program, has a terminal down here at the bottom, and then we'll actually pull up the code at the top when we're ready for that. So, okay, downloaded. So now off to the official code. So you've downloaded all the things already. Now let's start with the code. So let me open up the code. So this is, by the way, the Raspberry Pi. So I'm like FTP'd into the Raspberry Pi using an application called CyberDuck. It's basically the same thing as SSH, but instead of like the command line, I'm getting the actual files. So like JS, oh, let me refresh. There we go. So relay, everloop, and assistant. I'm going to do Command K, and that opens it up in VS Code. Going to move this one over here so it's in the right order. And okay, and I'm going to make this smaller since we don't need this right now. So this is the Everloop.js code. It's exactly the same as here, a little more colorful and a little better spacing, but it's the same thing as what we have on the guide. So I'm just going to rely on the code that is right here. So first off are the variables. You're going to initialize like a constant of matrix light, so it's knowing that we're using the matrix light library. I'm going to set up this methods variable so that so essentially how the code works is what you run in the end is the assistant.js file But in order to keep the code clean and modularized, we have these 2 additional files that assistant.js calls. So the everloop file, basically what it does is it sets up the wait word for the device. So when you tell it porcupine, it will hear that, and then it probably initialized right now. It'll listen to that, and then it'll do like a pulsing effect, sort of like an Iron Man arc reactor type effect. Kind of what you see on like Google Assistant and Alexa, similar. So that's what the methods will do. That's what the everloop.js will do. I mean, and yeah, I'll go through it. So waiting toggle, so it's going to toggle it, and then there's just a counter for doing the math from doing the pulsing effect. So set interval, just to make it run in a loop. Waiting toggle false. So if it's false, if it hears that the waiting toggle is false, then the LEDs will be set to black, which is essentially what this means. There's nothing. And then else if it's true, then it will do this fancy math, which you can look more into and play with yourself in order to make the pulsing effect. And then it has this counter, which just helps with the timing of the pulsing effect. So that's not too fast, not too slow. It's just right. It's like the 3 bears in Goldilocks. And then now the waiting method. So this, like when we're in the assistant.js file, it's going to call like everloop dot start waiting when it wants to set the toggle to true, and everloop dot stop waiting. Start waiting to true, stop waiting to false. And this is just the export for that so that it's accessible from other files. So that's the everloop part. Then the relay part. So let me explain what a relay is in case you don't know. I said it in the beginning already, but a relay inside here, it's basically just like, so there's 2 of them here. This is a board with 2. Yours can have 1, yours can have 5. It doesn't matter, it's however many you want. So inside here is basically an electromagnet that when we power it on using these cables going to the Raspberry Pi, so one of them's signal, one of them's power, one of them's ground, it'll essentially like the electromagnet will pull a lever in order to let the electricity flow one way or let it flow another way. So depending on how you have this wired, you want to have one always wired into the center. And then if you have it wired on one side, it'll by default start off as on. If you have it wired to the other side, it'll default start off as off. And then when you send the signal here to do one or the other, it'll just switch. So that's what it is. And this is all isolated. So, you know, this is handling like 120 volts versus this is like 5 volts from the Raspberry Pi. If you pushed, or well, from the Matrix Voice, if you push the 120 volts through the Matrix Voice, you would no longer have a Matrix Voice. So don't do that.
Yeah, very important.
Very important. That's why we don't connect directly. And you can see how small these wires are compared to these big terminals. Like, it doesn't compare. So
they would melt and melt together, right?
Yeah, they'd melt together and you'd have beautiful smoke, which if you're in the United States, it's almost 4th of July, so maybe that's what you want. But I don't. And we advise you, please don't do that. So now to the code. So here, again, declaring we want the matrix light library, the methods, so that this can be used outside of this file. But this is different. So now we have the relay pin. So this will be the GPIO pin on the matrix voice that the relay is connected to. So on the matrix voice, on the outside here, these are all GPIOs, and they're through holes. So you can access them from underneath and from up top, which is really useful because when we have it inside a case, we don't want wires coming out of the case. We want it to be all inside. So the actual wires can be coming from underneath, and you would never see it from the outside, which that was a great design.
Yeah, I love that design choice. I wonder if they actually like thought about that or if it was just a coincidence.
I mean, we did because we didn't want because otherwise it would just be really big, and we had the
Yeah.
space to do it. Um, yeah, yeah,
Well, that's good.
yeah. My thinking, my hands let go of it. Okay, but yeah, we were thinking of that. I don't think we envisioned this specific use case, but we were thinking a little bit about like ugliness of wires popping out. Yeah, and if in the matrix creator, like the GPIOs are accessible from the bottom, from underneath, but not from the top. But that's just because the matrix creator has less space. Like we'd have to make the board bigger if we wanted it to be on the top too. But the bottom
Yeah.
we're going to connect it to pin 0, which on the matrix voice, where's pin 0? Let me orient myself. Okay, so here's the matrix voice, right? So pin 0 is on the bottom, if you're holding it facing you, it's on the bottom left. I'm not sure what that is on the stream. And there's like a little 0 next to it. And it's labeled, and on our website we have a pinout diagram. So, you know, it'll be easy to figure out. And if you connect it to a different pin, depending on the pin, you can just type in like pin 1 or 3 or 5.2 there. But yeah. So the next part is setting the function. So we're using the GPIOs on here. So we're setting the function of pin 0 to be digital. So we're going to be giving it out a digital signal rather than analog, like analyzing the voltage of it. And then we're going to be setting the mode of pin 0 to be output. So it's not going to receive any information. It's just going to output a digital signal of either 1 or 0, on or off. So then we'll go down to the methods. So methods, when it hears like lights on, so when you call in the assistant.js relay.light on, it will run this function here. So it's setting the digital output of relay pin 0 to on, and then it'll just do a console.log light has been turned on. And then when you do relay.light off in the assistant.js, it'll set a digital output of the relay pin 0 to off and console.log that. And then this makes it accessible to files outside. So that's the entire relay file. It's, 19 lines if you include the comment, and then I have some spacing and other comments. Very simple, right? And now we're going to go to the assistant.js. So this is the part that handles listening to Rhasspy and then sending out the commands, the function calls to relay.js and everloop.js. So in it, we're going to require WebSocket. So that's requiring the WebSocket library that we got from NPM, the command I ran a little bit ago. Going to require the matrix light.js library, or matrix light in that case. And then HTTP as well. And then it's going to be listening to 2 WebSockets from Rhasspy. So one of them is WS, which is just WebSocket, and this is it. So the local host, so the local Raspberry Pi at this port. This is the same port, by the way, that's being used over here. So you can tell it's, they're related. It's all Rhasspy. And then it's going to listen to API events intent. So that will get, whenever there's an intent triggered, this will be listening to that, and then we can do something with it. Then the second one is wake. So this is for the wake word. So this was a new event added like a couple months ago, and that allows us to know when a wake word is triggered. So that's that. Then we're going to require the relay.js library and the everloop.js library. That way we can run the functions within them that we declared with the methods. And then, here's a console.log starting the web client. So this, when the WebSocket one that we're listening to. So this is the actual code of what starts happening. So when it listens to it being open, then it'll console.log that we're connected. So connection's good. So you see that, and the connection is good. If you see closed, then it's disconnected. Rhasspy has been pretty good for me in all my testing. I haven't really had issues with it. So hopefully you'll never have to see disconnected unless you're purposefully doing something like restarting Rhasspy. then on the wake word. So when it hears the wake word, just a message, it will send the everloop command, or call the function within the everloop file to start waiting. And so that'll do the pulsing effect. So that'll start the pulsing effect. Then here is what happens when we actually get data for an intent. So once we hear an intent, let me see if I have an example of the intent. No, I don't. Okay. So once we hear an intent, it'll trigger this function here. So it'll tell the everloop to stop waiting, because why we want it to stop waiting right there is by the time that we get the intent, Rhasspy has basically finished processing. And it's like confident of what it's heard to a degree. So it would already be time to stop waiting. And the time between it's heard that and that stop waiting and the code running is milliseconds. So it wouldn't be staggered or anything. So here's the data. It's JSON data, so it's going to parse it with JSON and then log out the data so you can see it on the logs. And then this is the actual logic for turning the light on and off. Pretty simple here. So, if it hears a light intent, so light is this. If it hears this, then equal to the data intent name. So the intent.name within the data, it'll have two cases. So it'll switch, it'll look for a slot.power. So this right here is the slot that it's looking for, the power. And then within that, it's going to look for what that data is. So if it says on, then it'll run the function relay.lightOn within the relay file, and that'll turn it on. If it's off, then it'll do the opposite. It'll do relay.lightOff, and then that is it. That's all the code. Super simple.
Love it.
Yeah, right? Cool. So now we're just going to wire the Pi, wire the relay to it. So here it explains you want to get VCC, ground, and in signal. So this is like a single relay module with VCC, ground, and in. Here, Rhasspy doesn't need to be so big, so I'll bring the guide up. And then you want to connect it to 5 volt on the matrix, ground on the matrix device, and then GPIO 0, or whatever other GPIO that you want. Maybe you're using GPIO 0 for something else already. So here we go. I'm going to connect it up over here myself because I can see at this distance. And then I'll bring it up to the camera so you guys can see. So if you're holding the matrix device, all the pins are labeled, so you can connect power VCC to the 5 volt pin, which is the second to last one on the right on the bottom row, ground to the last one on the right on the bottom row, and then signal to GPIO 0, which is the first one on the left on the bottom row. So have that plugged in there. So I'm doing it from the top right now because in order to plug them in from underneath, I have to unplug the Pi and then I'd have to reboot everything. Well, unplug the matrix voice, I mean. And I don't want to reboot everything right now. So here this is, right? So here's the relay, wires connected here, and then you can see here all connected up. Okay, cool.
Yeah, cool. I can see.
Great. And that's it for the wiring. That's it. I mean, you're going to have to connect this to your light switch. I'm not going to do that right now just because, well, I don't have like a light switch near me to do that with, and you're on a desktop, so bringing that to a light switch is difficult. Maybe if I had a Mac Pro with those fancy wheels, I could bring it. But this shows you everything you need to do. There's 2 live wires, a green wire. You don't need to use the green wire. Here's the light switch. I think If you're doing this, you've probably seen a light switch before. Make sure, this is very important, before unscrewing your light switch, find your breaker box and turn off the power to the switch and verify, like flick the switch a couple times, verify that it's not working anymore. That way you don't accidentally get electrocuted, because we do not want that to happen. So make sure you do that. And from there you can just touch the wires and you're good. So this explains like what wires you need to connect, a nice little diagram for it, and all that. And you know, safest method is, if you're wondering how to power the device, is you can solder some wires to some pins here. You can look up. So this, you know, this will void your Raspberry Pi's warranty by doing this. So up to you if you want to do that. But that's one way of powering it from underneath, instead of having like a micro USB cable, which wouldn't actually fit inside the case.
You're using a Pi 3, right?
I am using a Pi 3, yes. I'm not sure if they're the same pinouts on the Pi 4. They haven't changed pins since the Raspberry Pi, what, 1? Yeah, like 1. It's been the same. They've been the same pads.
Yeah. It's a little different now. I checked the back. It's not quite the same anymore because of the USB not being micro USB anymore. It's USB-C now. So a bit different. Okay. So beware if you're using a Pi 4, you might not be able to do that in the same way.
Yeah, so you know, do your own research, make sure you're confident about it. Yeah, do it at your own risk, essentially. And then if you want to power this, safest method would be using a power supply to externally connect to a plug. You'd have a wire going down. That's the safest thing. If you want to do some research to see if your light switch supports you powering the Raspberry Pi from the light switch, you can do that. We don't have instructions on that here because it's complicated, and best that you know it's better that you figure this out, and we don't want to be liable. So you can there's guides online for how to do this. So that's that. Printing the assembly. Oh, here, electrical tape. Oh, we need to add a space here. Oops. Make sure also for the relay. So the relay underneath this so I put electrical tape on the bottom of it. That's because like the contacts are there with the like 120. Like if I take off the tape really quick, you can see the contacts there. And you don't want to touch those when it's live. So make sure you put sufficient electrical tape underneath. And then printing the case. So the case is very simple. It's 2 parts. This part gets screwed onto the wall. So it has a hole here, a hole for the wires to feed through here, and then a hole on the bottom for the, well, to screw into the wall again. And then these little parts here where the other side of the case can fit on. So here, let me position this. Come on. So also the Raspberry Pi can screw onto this, so that make your life easier. But I didn't screw it on right now. So this is how it looks, but it would be centered if the Raspberry Pi is screwed into the case. And then you use screws here. So that's that. That's the case. We designed it. I designed it. And oh, here, we do show you how to solder to the back. So this will only happen for work for Raspberry Pi 3. We'll check it for Raspberry Pi 4 and update the guide. But we'll make a note that that's for the 3 and older. And then this is the case. That's it mounted. See, much better alignment there. And then that is that. So we've done all that. We've set up the code, 3D printed the case, wired it. Now for the grand reveal. Will it work? Fingers crossed. So what you want to do is you want to go back to VS Code or whatever terminal you're using, you want to type node assistant.js. Enter, and now it's running. So you see here, started WebSocket client, connected. So we know it's connected. And then now there is a light. I'm going to take it out of the case in 1 second. Now there's a light on the relay. This wasn't on before. So now if I tell it, Porcupine, turn the light on. Ooh, it did it. So now the light on the relay's off, and you saw the little pulsing effect. So let's do the opposite. Porcupine, turn the light off. Ta-da! It works! First try! That's so satisfying. Wow.
Woo!
Woo! Okay. Yeah, that's the entire guide basically. Super simple. I was very verbose talking about it. We can like see what's in the terminal now. So this right here that you're seeing is the output. So light has been turned on, wake word detected. So this was the second time I said it. Wake word detected, captured no intent. And this is the data from the intent. So intent name is light, entity power, value off. And then what we're looking for is the slot down here. We look for that it's a power slot. And then what the data is, it was off. And we read that, and the light has been turned off. And that's it. And it shows you like confidence, the tokens, like it shows you the text, the raw text. It's really good. You can do a lot of things with Rhasspy, and you can do a lot of customization with it.
Yeah, and basically like that's the JSON object, right? So if you wanted, you could definitely access the raw text and the recognized seconds. You can access any of those fields, right? So that's really impressive. And that's how you did the getting the slots and the name of the intent, right?
Yeah, exactly.
You did the data dot, yeah.
Yeah, see, so data.intent name. So here, bring this up here. So intent, data.intent, and then the name field, light, make sure it's light, and then data.slots power. So this is, the data, the dot slots, and the power, and it looks for if it's on or off, in this case off, and it ran that. And ta-da, it's done.
Yeah, it's so nice.
A combination of things. It could be a fan, it could be, technically you could also program this like with a web server locally to control a bunch of other light switches everywhere. So if you have one of these at every light switch in your office or home, then you could make a new intent on Rhasspy saying, Porcupine, turn all of the lights off. And it can look for that all slot as well. Like quantity, it could be a quantity slot, you could call it. And then it could communicate with all of the light switches and turn them all off or on. So there's a lot of options, there's a lot of customization. I triggered this and it's bright. There we go. It hasn't turned on. Oh, it heard me. So yeah, that's basically it. You want to show up both of us, Sam?
Yeah.
Cool. So if anybody has a question, you can type in the chat. We'll stay here for a couple minutes waiting. But yeah, I'm very happy that that worked first try.
Yeah, that's really impressive. Yeah, no, but I love how much you can do with Rhasspy, honestly. Like you were saying, you could like literally voice automate your entire house with Rhasspy. Even doors and fans and lights. It's just so cool.
Lamps, like anything. Yeah. Dog feeder. It's super
all these use cases.
And all we had to do on the Rhasspy side was go to their local website and just copy paste this. Like once we've done the setup, which by the way, the setup is telling it to use Porcupine as the wake word and just setting up the matrix device as the audio input as the microphone. That's basically it for setup. Super simple, and you can play in you're looking like, oh, what other wake words are there? Like tent handling, and see, there's wake words, pocket sphinx, snowboy, Minecraft, and then we're using porcupine. Oh no, it triggered again. It's so bright.
Yeah. I think what's really nice also about Rhasspy is what you were saying, where you can like swap out different speech to text engines, different wake word engines. If you like Minecraft better, then do that. Somebody just asked a question: is it possible to change the wake word? Yes. I had put a comment about this earlier. You can check out the Rhasspy documentation, and it'll tell you how you can change it. It depends on which wake word engine you're using. So if you're using Snowboy, you can customize your wake word. And I think there are some other ones, other wake word options as well, where you can customize your wake word. But let's put the link to the documentation back in there so you can check it out.
And on the Rhasspy like local website, it even has a little tooltip, like see documentation for how to use multiple wake words.
Oh, there we go. Yeah, multiple wake words, custom wake words, all of them. So that's super cool that you can also do multiple wake words.
Yeah, maybe for like different people in the house can have, or the office can have different wake words. So different permissions. Just don't let anybody know your wake word. It's like a password.
It is kind of like a password. But yeah, I guess since we've covered most of the content, people can still ask questions. We're just gonna, I guess, go over some announcements. Just one announcement, really. But we're, Matrix Labs is, to reiterate, our mission is to basically make difficult technologies easier for everybody by making hardware and software tools. So you all know at least now through this live stream that we have the Matrix voice and the Matrix creator, and a software stack to really easily program it, like with JavaScript and things like that. But right now what we're doing is we're preparing for our next phase, which, we're trying to bring even more technologies to you. And for that, we're raising a seed round, which, people can, it's like a crowd, the same way we crowdfunded the boards, this is also crowd investment. So if you're interested, you like Matrix Labs and you want to contribute and join our journey in creating the next, AIoT technologies, then, feel free to check out our Fundable page. I'll put a link right here, and you can check out what we're all about, and see if you want to invest. And you can always talk to us about it and ask us questions if you have them. But yeah.
And on screen, I have the Fundable link, and you're seeing the Fundable page here. So already raised 85K, and you can check it out, read the whole thing here. And if you sign up, then you can see this locked section for the business plan. So yeah, please check that out. Spread the word. That's it.
Yeah. And, thank you for joining our first quarantine live stream. And if, you have any comments or suggestions on how we can improve, let us know. And we're hoping that we can, continue to keep this recurring. You can see how I'm refraining from saying how often, because I'm not sure how often we can do that yet. But it will be recurring, and we'd love to have you, discuss with us, ask us questions and things like that. Yeah.
Yeah.
All right.
Well, thanks everyone for watching, and we'll see you next time.
See ya. Bye.